Now let's prove that the limit of xn as n approaches infinity is equal to 1, and that xn is equal to n over n plus 2, and n is equal to 1, 2, 3, and so on, positive integers. So let's prove it using the limit definition. Given any epsilon equals to epsilon 0, as long as we are able to find an integer n with n, the small n, greater than a large or a capital N, we have that this inequality n over n plus 2 minus the limit, which is 1, smaller than epsilon 0, holds. So as long as this inequality holds with an integer n with sorry, how about I say it like this? As long as we are able to find a capital N such that small n is greater than capital N, and that this inequality holds, we have proven this, right? We have proven it. So then, how do we actually do it? Well, then we actually solve this inequality. So here, if we solve this inequality, well, we can write this inequality as n over n plus 2. This is going to be greater than 1 minus epsilon 0, and this is going to be smaller than 1 plus epsilon 0. And then we're solving two parts here. We're solving this part right over here, and we're also solving this part right over here. So we're going to write 1. We're solving n over n plus 2 is greater than 1 minus epsilon 0. And that n over n plus 2 is smaller than 1 plus epsilon 0. Okay? So then let's solve these two parts. So solving for part 1, well, we can multiply n plus 2 on both sides, so that n is greater than 1 minus epsilon 0 and times n plus 2. Okay, so let's multiply. So then the result we get here is n and then plus 2, and then minus epsilon 0 times n, and minus 2 epsilon 0. So then you can cancel out these two, and now we are going to solve for n. So you move this here on, you move epsilon 0 n onto the other side, so then that's epsilon 0 n is greater than 2 minus 2 epsilon 0. Now, if you were to divide oh, by the way, we are able to divide here because we know that epsilon 0 is always going to be a positive number. So we can divide. So n is greater than 2 over epsilon 0 minus 2. So then we've got this part done. We have n is greater than, I'm going to write it here in this corner, 2 over epsilon 0 minus 2. Okay, so now let's solve for the second part. Um, the second part, we again multiply n plus 2 on both sides, so then that's n is smaller than 1 n plus 2 times 1 plus epsilon 0. Okay, so then n is smaller than, you multiply through, that's 1 times n plus n times epsilon 0, or we can write epsilon 0 first. So epsilon 0 times n, and then plus 2, and then plus 2 epsilon 0. Okay, so then these can cancel out. And now we're actually going to move this 2 over, and we're also going to move 2 plus epsilon 0 over. So we're going to write it like this. So epsilon 0 n stays on on this side, and we have negative 2 minus 2 epsilon 0. So then divide epsilon 0 on both sides, and we can do this once again because epsilon 0 is greater than 0. So then that's a negative 2 over epsilon 0 minus 2. So then we have here n is greater than, let's see if I can write this with more space here. So n is greater than negative 2 over epsilon 0 minus 2. Okay, so now that you have these two, I'm going to erase I'm going to erase this part. So so we got this from here, right? We got this from here where we had to solve two parts, right? So this means that these two need to intersect. You need to get the intersection of these two solutions, right? So here n has to be greater than 2 epsilon 0 minus 2. But at the same time, and at the same time, it also needs to be greater than negative 2 over epsilon 0 minus 2. Okay, and I'm just going to write this sign here like this, and is greater than that. Okay, so I'm missing a negative sign here, so negative there. So here, these two need to intersect. You need to find the intersection to get the solution. So what is the intersection where these two are both satisfied? Well, notice that here, n has to be greater than this, n has to also be greater than this. So n is greater than this and that, right? Now, if we have this, if we have a scenario where n is greater than two things, we just need to find the solution is just going to be n is greater than the greater value, right? For example, if n is greater than 3 and n is greater than 4, then, well, you're just looking at n greater than 4, because if these two need to be met, well, then you're just looking at n is greater than the greater value. So then in this case, which one is the greater value? Well, it's this one here, because this one is positive. Let's see if I can highlight this like this. So this is the one that we're looking for, because here 2 over epsilon 0, that's positive, whereas here this is negative 2 over epsilon 0, and epsilon 0 is always positive. So in this case, we're just looking at n is greater than 2 over epsilon 0 minus 2. Okay, so if we know this, well, what is n equal to? Well, remember, n is equal to the ceiling of, here, maybe I should give this more room, so I'm going to write it here. N is greater than 2 over epsilon 0 minus 2. Okay, there we go. So then n is equal to the ceiling of 2 over epsilon 0 minus 2. And this is our proof. We found such a value for n. Because here, epsilon 0 is greater than 0. It's any positive value, which means if epsilon 0 is any positive value, then of course you can find a value for n in this case. Of course it is possible to find a value for n in this case. And therefore, you have proven it.